In this video, we will discuss how to combine tables using Proc. We will discuss two different ways to combine tables. So they are joins and set operators. For joins, it means we want to combine tables horizontally. Just means like we put data side by side and want to merge them together. So this corresponds to matching merge in data step we discussed before. There are two types of joins. The first one, inner join, returns only matching rows, allow a maximum of 32 tables to be joined at the same time. The other one, called outer join, it returns all matching rows plus non-matching rows from one or both tables. It can be performed on only two tables or views at a time. For set operation, it combines tables vertically, just like one on top of the other. So this corresponds to concatenating we discussed before in data step. First one to combine the table, so this is called a Cartesian product. A query that lists multiple tables in the form clause without row restriction, resulting in all possible combinations of rows from all tables. So this is called Cartesian product. So look at this statement. Select star, so means we want to pick all variables from data, right? So in the form clause, so here we list the name of two data sets separated by comma. So in the resulting for this query, so it will produce all level combinations. All combinations of rows from both tables. So the number of rows in the Cartesian product is the product of number of rows in the contributing table. Yeah, so let's show that in an example. Because we need to use many different tables, right? So here I just create a data 1, data 2, data 3, and data 4. So they will be used in a while. First one is Cartesian product, right? So I just proc print data equals 1, proc print data equals 2, right? So I show data 1, data 2, and also the result of Cartesian product together. You can see in data 1, we have 3 rows. In data 2, we have 3 rows. And so in the resulting query, so we have, 3 by 3, we should have 9 rows in total. You can see, we have 1A, 1A, 1A. So this corresponds to the first row of the first data set, right? See, 1A is combined with 2x, 3y, 5v, right? So they corresponds to each row of the second data set. And so then we have 4D, 4D, and 4D, corresponds to the second row of the first data set. So then we have 2x, 3y, 5v, right? So the second row is paired with each row in the second data set. And so the last, so we have 2b. 2b is the last row in the first data set. So this row is combined with any row, with every row in the second data set. So in the end, so it results in 9 rows. So this is a Cartesian product. And so SAS will keep all variables, right? See, those are variables in the first observation, first data, and so XB. So this is the data set. The variables in the second data set. Well, so for inner joins, so inner joins resembles a Cartesian product, but it has a where clause that restricts how the rows are combined. So we will write it in this way. So select columns 1, columns 2 separated by comma, right? So you just specify which variable you want to include it in the resulting query. And so from, the table 1, comma, table 2. So the name of the data set, so separated by comma. The while clause, so you just specify so how rows in the first table so is matched with rows in the second table. Yeah, so see it displays all combinations of rows with matching keys. Yeah, so including duplicate. So like this as an example, we select the 1.x. So what's this? This is just how we refer to variable. Yeah, so particularly so if there are different variable with the same name, right? So this is just like the name of the data set and dot. After that, so we will have name of the variable. Yeah, so 1.x just means the variable x from the same from the first data. Yeah, from data 1. A and B, so we didn't write specify the name of the data set. Yeah, because in these two data set, right? So A only appears in the first data, and so B only appears in the second data. Yeah, and so there is no need to specify the name of the data set. So it will not cause any confusion. So we just pick those rows from these three. We pick these variables from these two data sets, right? Where just specifies how the rows are matching. Yeah, so so x, 1.x equals 2.x. Yeah, so just means when the x in the first row corresponds to x in the second row, right? When x in the first data set equals that from the second data set. Yeah, so maybe we can run these together and to see what the result will be. So the first one is Cartesian product, and so the next one is the inner row. I think conceptually, so we can think this in this way. Maybe so SAS will first produce this Cartesian product, and so in the while statement, and so SAS just pick so which rows will be included, right? Yeah, so see 1.x equals 2.x. If you look at the result of the Cartesian product, you will notice 1x equal to 2.x. So only this rule so satisfies that condition, right? And for the remaining rows, 1.x and 2.x, so they are different. Yeah, so this is why in the product we have only one row left in this query. So if you so if you use star, right, all variables in both data set will be included in the result of query. So this is what we mentioned. Yeah, so you just pick, yeah, because since in here, so you have 2x, right? So in fact, the value are the same, so there is no need to keep both. We can only keep one of them. So then I specify 1.x, comma a, comma b. Yeah, just pick these three variables. Yeah, so this is the result of the query. Yes, look at here. So for data 3 and data 4, maybe we check another example. Data 3 for print data 4, right? So then we select all variables from the both data set, and so we want the 3.x equals 4.y. Yeah, so that's basically we the while clause specifies how the rows are matched. Yeah, so look at the result. See, the reason we show that is because here we have two the value of x is not unique, right? And so for the second one, so the value of x is also not unique, right? And so when we do matching, I mean just match them by the value of x, so you will see, so these two rows will be matched with these two rows. And so then in the result, so SAS just do a Cartesian product. So in the result, we will have 2 by 2. We will have 4 rows in total, right? You can see we have 2 B1, see 2 B1, 2 B1. So this row of the first data is matched with, see, 2x1, 2x2, right? See, 2x1, 2x2. So this row in the first data is matched with any row in the second data with x equals to 2. And so similarly, so for the second row, so 2 B2, right? Okay, right. So here, so it is matched with any row in the second data. This behavior is so slightly different from the many-to-many merge in data step, right? So for many-to-many merge in the data step, I mean, if you use the merge statement, yeah, so SAS will only result in 2 rows, yeah, but in Proc SQL, so SAS just do Cartesian product. Then for outer join, yeah, so for outer join, so you can retrieve non-matching rows as well as matching rows by using a outer join. Yeah, so outer joins are limited to 2 tables at a time. So I just use this diagram just to illustrate 3 different types of outer join. Yeah, so we may have left join, full join, or right join. For left join, so we will keep all rows in the left table, and so then include the matching rows in the right table. When we say left, right, because every time we have only 2 tables joined together, right? Yeah. So left join just include all rows in the left table plus matching rows in the right table. For full join, so we just include every rows in both table, right? And so for right join, so we keep all rows in the right table, and so we'll only include matching rows from the left table. So this is how we write the code. So we will say select, so you just list the name of the columns you want in the query. Make sure to separate them by comma. From, see, table 1, table 2, right? And so between them, so you will say either left join or right join or maybe full join. So according to which type of join you want. So then on. So after on, so you just specify join conditions. Yeah, so join conditions just specifies so how the rows are matched together. Yeah, after that, so you may have some other clause. Okay, yeah, so let's try some example. For here, so I want to use a left, I mean the data 1 left join data 2 on x equals 2.x. So here I also print the contents of the data 1, print data 2, right? And so then we also print out the result of this query. So notice, yeah, let's check here. See, the first one is data 1, right? See, in the resulting data set, you can see for the 2 variables in data 1, we have x and a, right? So the originally the first data has 3 rows. So here we also have 3 rows. So they corresponding to so the rows in the first data set. For the second data set, yeah, because so only this guy, so 2x, so this has a match with the value of x in the first data set. So then you just match this one to here. Yeah, but in the second data set, so the value, I mean, x does not have the value of 1 and 4, so there's no matching row, right? So then the result will be missing. Yeah, so this is left join. So if we do right join, so 1 right join 2, okay. Maybe we also include the data 1, data 2 here. Yeah, so similarly, right, but just opposite. Okay, so for the second data set, so we add X and B, right? See, for this part, so this is exactly the second data set. And so for the first part, for X and A, right, see, only one row here, so has matching row, has matching value of X with the second data set. And so we have missing for this position. So this is this is right join. And so the last one will be full join. Yeah, so full join, so we will include all matching rows and non-matching rows. Right, you can see 1A, 2B, and 4D, right? Yeah, so this corresponds to the rows in the original data, I mean original first data. See, 2x, 3y, and 5v. So this corresponds to rows in the second data set. Yeah, so we just match them. So if they have the same value of x, so we will match them together. Otherwise, the value will be missing. Yeah, so this one I think looks very much like match merge in data step. So if you use a merge statement. The last one is the table aliens. So why we want to do that? See, every time, so when we refer to a variable, right? So we will say the name of the data set and then dot and then name of the variable. Yeah, so sometimes the name of the data set may be too long, and so then we can create a alias and to make it easy to write. So a alias is a table nickname. So you can assign a alias to a table by following the table name in the form clause with the S keywords and a nickname for the table. And so then use the alias in other clause of the query statement. You can see after the one, so then we say as a, right? So then a so can be used to refer to data one. So 2 as b, right? So for the second data set, yeah, so we call it b. So then you can use b to refer to the data 2. Yeah. So see, then we say a dot x and b dot x, right? So then this is equivalent to say so 1 dot x and 2 dot x. So let's check this in here. So it should produce the same result, right? So this is a right join, right? Yeah. So it should produce the same result. So this is just a alias, table alias. This is a summary and a comparison between the data step merge versus the SQL join. So data step merges are usually more efficient than SQL join in combining small tables. Yeah, but for large tables, usually SQL will be much more efficient. And so Proc SQL, so join do not require sorted or indexed table. So this is very convenient. So do you still remember? So when we use merge to combine data, yeah, because merge, so usually we have a by statement. So as long as we have a by statement, and so data should be sorted before that. Yeah, but if you use a Proc SQL, no need to sort the data. And Proc SQL join does not require that the columns in join expression have the same name. Yeah, see, like here, here, so they have the same name, right? So both of them are X. Yeah, and so in merge statement in data step, so in that by, so after by, right? So if you want to merge two data sets, so by a variable, so that variable must have the same name and appear in both data set. Yeah, but for SQL, so not necessarily. So look at here. So we have select so some columns, right? So from table A and table B. Yeah, so in the where statement, see, we just specify, so a dot it number equals b dot I num, right? So they do not have the same name. Yeah, so this is fine in SQL. In data step, so if we want to do that, I mean, if we want to merge by these two variables, we need first rename one of the variable, and to make sure they have the same variable name, and then we can merge them. Yeah, but in SQL, so not necessary. And another advantage of Proc SQL is, so for this comparison, additional to equal sign, we can also use this greater, right? So means we only keep rows, so such that the cost in the first table, so it's larger than the price in the second table. Yeah, but this is not allowed in if you use merge statement in data step. So generally, as a summary, Proc SQL so is more efficient for large table, and so it is more flexible in many scenarios. So next one, so we will discuss set operation. So set operation combine rows from two tables vertically. So there are four types of set operation. So except, intersect, union, and outer union. For except, intercept, and union, so by default, so columns are matched by position and must be the same data type. Maybe I show you this one first. Yeah, so then what is except? So except, so for these four types of operation, right? So they can be illustrated by this four diagram below. So for except just means, so it will keep a unique rows from the first table that are not found in the second table are selected, right? So basically just pick rows appears only in the first dataset but not in the second dataset. So intersect just means we want to combine, I mean, we want to pick rows from both tables. Yeah, just like this intersection. Union just means, so all rows just will be combined together. Yeah, so this is union. Outer union just means, so all rows from both tables as well as, I mean, it doesn't matter, so it is unique or non-unique. So all of them will be selected, and so column will not be overlaid. Yeah, so that's four types of set operator. And for except, intersect, and union, so columns are matched by position and must be the same data type. And column names in the resulting set are determined by the first table. For outer union, yeah, so all columns from both tables are selected. Yeah, so let's try some example. So we have data 1 and data 2. Okay. First one, select everything from 1 except everything from 2. Yeah, so just means we want to print data 1, print data 2. So it means we just want to we want every rows appears in the first dataset but not appears in the second dataset, right? You can see for the second, let me see. So yeah, we have in the resulting dataset, right? You can see we have 1A, yeah, because 1A does not appear here. We have 1A. See, because there are two 1A, right? And so because in the resulting dataset, we only save a unique rows. Yeah, so this two of 1A in the result, we have only 1A. And so then we have 1B because it does not appear here. So in the resulting dataset, we have 1B. And so similarly for 2C, but for 3V, yeah, because for here we have 3V, right? So in the result data, so we do not have 3V. Yeah, and so 4E and 6G, and so we have this in the result of query. So basically just remove rows that appears in the second data set, right? And so also remove duplicate rows. So notice the name of the variable are different, right? We have XA, we have XB. Yeah, but the SAS will ignore that. Yeah, because by default, so this operation is conducted by the position. Position, I mean the position of variables. Okay, right? And so the name of the variable will be the same as the name of the variable in the first data set. Yeah, so this is here. Or notice, so except or. So what's that? There's some modifier so can be used to modify the behavior. So or just means do not remove duplicate rows, right? And so by this way, so it can avoid an extra pass through the data. Yeah, so if you do not use these modifiers, so SAS will remove duplicate rows. Yeah, so see with this one, we run it, maybe we run both, so then we will notice the difference. You can see we have only 1A here, but we have 1A, 1A. Yeah, because still remember, in the first data set, we have 2 rows of 1A, right? So the both rows are kept. So in the resulting query. What is core? CORR? Corresponding. So just means, so we will do the overlay. I mean, just by the name of the columns instead of by position. I think so. This will make more sense, right? Yeah. So you can say core or maybe corresponding. Okay. Yeah. So it will remove any columns not found in both table when used in except, intersect, and the union operation. Let's run this one. You can see, so in the result, maybe let me show you that one for, let me also show the data 1 and the data 2. Yeah, so in this one, so because of we have cross, right? So this just means, see, this has A and this has B, right? So basically, so this variable, so with a non-matching variable, so because they have different names, so they will be kind of dropped. Okay, so will be ignored. Yeah, so when for this operation, so we only work with X and work with X. We have 1 here. Yeah, so this X also has 1, right? So basically, 1 is not selected. So first data set has 2. So this also has 2, not selected. It has 3. It also has 3. But the 4 and 6, so there's no 4 and 6 in the second data set. So in the result of the query, so we have 4 and 6, right? Yeah, so this is the result of correspondence. Yeah, so similarly, so let's check the intersect. Intersect. So intersect, so this will just we will only save common rows. For this one, we only say intersect, right? And so no other option. So this means SAS will do this operation by position. Yeah, so we have XA. So the only common row will be 3V, 3V, right? So 3V here and 3V here, okay? Yeah, and so although they have different variable name, we have A here, we have B here, but cause SAS do this operation by position, right? And so the name of the variable is used as the name of the variable from the first data. So then we use the CORR corresponding, right? Yeah, so then by this way, so SAS will do this operation by matching by matching the name of the variable. Yeah, so first data we have A, so then we have B. Okay, so then A and B, so this unique variable, so will be ignored. Yeah, so then SAS do this operation so only for variable x. And so then we want in the result of the query just will be the unique entry or unique row that appears in both dataset. Yeah, so then we can see 1, 2, 3. We have 1, 2, 3 in the first one and also 1, 2, 3 in the second one, right? But for those unique row like 4 and 6 or maybe 5, so they are removed. Yeah, so then we have, this is why we get this result. So then look at union. So for union, and we just basically combine all rows from both dataset. Yeah. See, this one, first one we have 7, this one we have 5. We just SAS just combine them. I mean, just combine all rows together, and so then remove duplicate rows. Yeah, so then this will be the result we have. So they have different variable name, so A and B, right? But SAS do this operation by position. Yeah, so the name of the variable comes from the first dataset. Yeah, so this is why we have this result. And so if you use CORR corresponding, okay, so then you do this one, SAS will do this operation by names, right? And so A and A will be ignored. Yeah, so SAS do this operation by variable x only. So in the resulting value, so we have every row from both data. Yeah, see, we have 1, 2, 3, we have 4 and 6 here, right? So 1, 2, 3, we have 5. So in the result, we have 1, 2, 3, 4, 5, 6. So this is then for outer union. Okay, so outer union. So SAS will combine all rows and all columns. You can see compare with this figure, right? See, we have all rows and all variables seems combined in this way. Yeah, so then see, we have XA and XB. So SAS will have XA and XB. So the first, this part just corresponds to all rows from the first dataset, and in the remaining here, all rows from the second dataset. Yeah, and so then we have basically, so then this part SAS just fills them as missing. By default, so out union, so we have or. See, basically, so this or, so this is not allowed in connection with outer union operator. So this is implicit. Implicit, you mean, well, what I mean is, so even if there are some duplicate rows, so SAS will not remove them. Yeah, so SAS will keep all duplicate rows. For the next one, yeah, so this is you can also do corresponding, right? So for the outer union, I think we have it. Yeah. See, for outer union, so if you use corresponding, so cause common columns to be overlaid. Yeah, because by default, so SAS, see, even this XX, they have the same name, so SAS will treat them as different. Yeah, but if you use this corresponding modifier, then SAS will see X will be matched together. Yeah. So this is just except intersect, union, and outer union. Yes. Yeah. So then, as a summary, so Proc SQL so is very flexible and powerful when you want to combine tables. So you can combine table side by side. Yeah, so just means join. And so you can also combine table, up and down. So for up and down just means like we stack them one on top of the other. Yeah, so in this case, we use a set operator.